One of the world's most respected astrophysicists just called NASA's images deceptive. Not exaggerating, not making a mistake, lying. And what makes this accusation so explosive is that it's coming from someone who has everything to lose by making it. A Harvard professor with hundreds of peer-reviewed publications. A man who is former chair one of the most prestigious astronomy departments on Earth. His name is Avi Loeb, and when he looked at the images NASA released of 3i Atlas, the interstellar visitor that's been captivating the world for months, he didn't see scientific triumph. He saw deception. He saw an institution presenting blurry, low-quality images as if they told us something definitive when, in his words, they told us almost nothing at all. And here's what should terrify anyone who values truth in science. When you compare what NASA showed the world to what amateur astronomers captured with backyard telescopes, you'll see immediately why millions of people are now questioning everything we've been told about this mysterious object hurtling through our solar system. Stay with me, because in the next several minutes we're going to dissect exactly what went wrong with NASA's 3i Atlas images, why a scientist of Loeb's caliber would risk his reputation to call them out, what those 13 specific anomalies are that NASA didn't want to emphasize, and why December might reveal something that changes everything we thought we knew about visitors from beyond our solar system. You've been waiting for months to see what NASA would show us. Since the moment 3i Atlas was confirmed as an interstellar object, we've all been holding our breath. This wasn't just another space rock. This was a visitor from another star system, only the third interstellar object ever detected passing through our cosmic neighborhood. Do you remember the excitement? You remember refreshing NASA's pages, watching space news channels, counting down the days until the images would finally drop. This was supposed to be historic. This was supposed to give us clarity. And when NASA finally unveiled those images in November, after processing delays NASA attributed to technical challenges, what did we get? A fuzzy ball of light. An elongated smudge. Something that told us less than what amateur astronomers had already captured weeks earlier with equipment you could buy online for a few $1,000s. If you felt let down, you weren't alone. If you looked at those images and thought, that's it, that's what we waited months for, you were part of a global wave of disappointment that swept across social media, astronomy forums and science communities everywhere. People were angry. People were confused. But most people shrugged it off as just another example of governmental bureaucracy moving slower than private citizens, another case of red tape getting in the way of discovery. Most people moved on, but not Avi Loeb. Because when Loeb looked at those images, he didn't just see technical failure. He saw something more troubling. He saw an institution making definitive claims based on evidence that couldn't possibly support those claims. He saw NASA telling the world, this is definitely a comet, when the quality of the images made that conclusion scientifically premature at best and deliberately misleading at worst. Let me read you exactly what Loeb wrote on his blog just days after NASA's press conference. He said, and I'm quoting directly here, the images are deceptive. They show us a fuzzy blob and ask us to accept certainty when none exists. This is not how science works. This is how institutions protect narratives. Those are fighting words in the scientific community. When a Harvard professor accuses NASA, not just of being wrong, but of being deceptive, you know something significant is happening. This isn't professional disagreement. This is a direct challenge to institutional credibility. And Loeb wasn't done. He went further, pointing out that the images NASA chose to release, the ones they held a press conference about, the ones they presented as evidence of 3i Atlas being a normal comet, were so low in resolution that they couldn't rule out alternative explanations. They couldn't distinguish between a natural object and something else entirely. Now, before you dismiss this as conspiracy thinking or scientific drama, consider this. Avi Loeb isn't some fringe researcher with a YouTube channel and a theory about ancient aliens. He's the former chair of Harvard's astronomy department. He's published over 800 scientific papers. He's advised NASA, the Pentagon, and multiple international space agencies. His work on detecting exoplanets and studying the early universe has shaped modern astrophysics. This is not someone who makes accusations lightly. This is not someone who traffics in sensationalism. And yet here he is, publicly stating that NASA's presentation of the 3i Atlas images was scientifically dishonest. Why would someone with everything to lose say something so inflammatory? What did he see in those images? Or rather, what did he not see that made him so certain NASA was misleading the public? Sherlock Holmes once said, "There is nothing more deceptive than an obvious fact." And that quote captures exactly what Loeb is arguing about these NASA images. The obvious fact is, look, there's 3i Atlas, we photographed it, it has a tail, it looks like a comet, case closed. But the deception is in what that obvious presentation hides. It hides that the images are so blurry they can't actually tell us much of anything. It hides that NASA had access to much better data they chose not to emphasize. It hides that amateur astronomers with vastly inferior equipment captured more detailed images. And most importantly, it hides that the object exhibits behaviors that don't fit neatly into our understanding of natural comets, behaviors that NASA acknowledged in technical papers, but downplayed in public presentations. The internet erupted, as it always does when institutions appear to contradict themselves, or when David takes on Goliath. Within hours of Loeb's blog post going live, it was shared thousands of times. Amateur astronomers posted their own images side by side with NASA's, and the contrast was stark. People who had never questioned NASA before started asking uncomfortable questions. Why would the most advanced space agency in human history release images that were inferior to what hobbyists could capture? Why would they present those images with such confidence, declaring the object definitely a comet when the evidence was so inconclusive? And why would they schedule a press conference, build anticipation, and then deliver something that looked like it was photographed through a fogged window? You deserve to know what's really going on here. You deserve to understand why a scientist of Loeb's caliber would risk professional backlash to speak this truth. You deserve to see the evidence that NASA presented versus the evidence they didn't emphasize. Because this isn't just about one interstellar object. This is about how institutions shape narratives, how scientific certainty can be weaponized to shut down legitimate questions, and how the most important discoveries can be hidden in plain sight behind blurry images and confident press releases. This is about whether we, as a civilization, are being told the whole truth about what's visiting us from the stars. Now, I want to be clear about something before we go any further. This isn't an anti-NASA rant. I'm not here to tear down an institution that has given us extraordinary science and pushed the boundaries of human knowledge. NASA has achieved miracles. They've landed rovers on Mars, sent probes beyond our solar system, and shown us images of the universe that have changed how we understand our place in existence. I respect that. Loeb respects that. But respect for an institution doesn't mean blind trust. It doesn't mean accepting narratives without examining evidence. It doesn't mean we should stop asking questions when something doesn't add up. And when it comes to 3i Atlas, something very clearly doesn't add up. The question we're going to answer in this investigation is simple. What exactly is wrong with NASA's 3i Atlas images, and why does it matter? We're going to break down the technical problems Loeb identified. We're going to examine the 13 specific anomalies he documented that suggest this object might be far stranger than a normal comet. We're going to look at the amateur images that embarrassed a space agency. We're going to hear NASA's defense and evaluate whether it holds up to scrutiny. And we're going to explore what might really be going on with 3i Atlas, not through speculation or wild theories, but through careful analysis of the evidence both sides present. But here's what makes this story so urgent. December is coming. In just weeks, 3i Atlas will make its closest approach to Earth, passing within observable range of our most powerful telescopes. Hubble will get its chance. James Webb will analyze its composition. Ground-based observatories around the world will focus their instruments on this visitor, and when they do, we'll get data that will settle this debate once and for all. We'll know if Loeb is right to question the comet narrative. We'll know if those anomalies are real or just statistical noise. We'll know if NASA's confidence was justified or premature. But right now, in this moment before December's revelation, we have an opportunity to examine what we do know, what we don't know, and what we're being told versus what the evidence actually supports. If you're the kind of person who thinks questioning NASA is automatically conspiracy thinking, I invite you to suspend that judgment for the next hour and just look at the evidence. If you're the kind of person who immediately assumes NASA must be hiding something, I invite you to consider their perspective fairly. The truth, as always, is more complex than either extreme. And the only way we get to that truth is by examining what both sides are saying with equal skepticism and equal openness. That's what scientists are supposed to do, that's what Loeb is doing, and that's what we're going to do together right now. So hit that like button if you believe we deserve better explanations when it comes to objects visiting us from other star systems. Drop a comment telling me whether you think institutional credibility should be questioned when evidence doesn't match conclusions, or whether we should trust NASA's expertise over independent analysis. Because this conversation matters. How we handle discoveries like 3i Atlas will determine whether humanity approaches the cosmos with genuine curiosity or comfortable assumptions. And right now, comfortable assumptions are being challenged by a Harvard professor with receipts. Let's dive into what NASA actually showed us, and why it immediately raised red flags for anyone paying close attention. Let's examine the images that sparked this controversy and understand exactly what we're looking at, and more importantly, what we're not looking at. November 19th, 2025. That's the date when everything came to a head. NASA's Goddard Space Flight Center held a press conference that had been anticipated for weeks. The space agency was finally going to reveal what their spacecraft had captured of 3i Atlas, the mysterious interstellar visitor that had been generating headlines since its discovery. You remember the build-up, the teasers on social media, the cryptic statements from NASA officials about promising observations and significant data collection. The astronomy community was buzzing. Forums were alive with speculation. Everyone wanted to see what our billion-dollar space infrastructure had managed to photograph of this rare visitor from beyond our solar system. And then the images appeared on the screen. The room went quiet. Not the kind of quiet that comes from awe, but the kind that comes from confusion mixed with disappointment. There, displayed on NASA's official presentation slides, was 3i Atlas. Or rather, there was something that NASA said was 3i Atlas. It looked like an elongated, fuzzy blob with a faint tail structure extending behind it. The image was blurry, indistinct, lacking the kind of detail that everyone had been hoping for. It told us the object had a coma, the cloud of dust and gas that surrounds active comets. It told us there was some kind of tail, suggesting outgassing activity. But beyond those basic observations, it told us almost nothing. You couldn't see surface features. You couldn't distinguish structural details. You couldn't even be entirely certain about the object's precise shape because the resolution was so poor. The images had been captured by the high-res camera aboard the Mars Reconnaissance Orbiter, one of NASA's most sophisticated imaging systems designed to photograph the Martian surface in extraordinary detail. This camera can resolve features as small as furniture on Mars. Its captured images so clear you can see individual boulders casting shadows on the red planet's surface. And yet, when pointed at 3i Atlas, it produced images that looked like they'd been taken through petroleum jelly. NASA also presented data from the MAVEN spacecraft, another Mars orbiter, which had attempted to observe the interstellar visitor during its passage through the inner solar system. That data showed spectroscopic signatures consistent with water vapor and some organic compounds, again consistent with cometary behavior, but nothing definitive, nothing that couldn't be explained by multiple scenarios. Amit Kshatriya, NASA's Associate Administrator for Science, stood at the podium and delivered the agency's conclusion with absolute confidence. "This object is a comet," he said. "It looks like a comet, it behaves like a comet, and our observations confirm it is a comet. While it originated outside our solar system, it is fundamentally similar to the comets we've studied for decades." He acknowledged the image quality wasn't perfect, but explained that photographing a fast-moving interstellar object from spacecraft designed for other purposes presented unique challenges. He mentioned the government shutdown that had delayed data processing by several weeks, a delay that had frustrated the public but was, according to NASA, unavoidable. And then he opened the floor for questions, expecting the usual technical inquiries from science journalists. Instead, the online reaction was immediate, with social media comparing amateur images sharper than NASA's. The room tensed. Kshatriya handled it diplomatically, explaining that different observing conditions and different types of cameras produce different results, that spacecraft data provides spectroscopic information ground telescopes can't easily obtain, that these images were part of a larger dataset including measurements invisible to amateur equipment. But the question had been asked. The elephant was in the room. The internet had already seen better images of 3i Atlas from people using backyard telescopes, and now NASA was presenting something inferior and calling it definitive evidence. Let's be clear about what NASA was showing and what they were claiming. The images showed an elongated object, that much was certain. They showed a coma surrounding the nucleus, indicating active outgassing. They showed a tail structure extending away from the Sun, exactly what you'd expect from a comet being heated as it approaches our star. All of these features are consistent with cometary behavior. NASA wasn't fabricating data. They weren't photoshopping fake images. Everything they presented was real. But here's where Loeb's criticism becomes important. Real data can still be presented in misleading ways. Incomplete data can still be used to make premature conclusions. And low-quality images can still be framed as providing answers they're not actually capable of providing. NASA's presentation emphasized what the images showed and de-emphasized what they didn't show. They focused on the comet-like appearance and brushed past the anomalies. They highlighted the tail and downplayed the unusual characteristics that didn't fit standard cometry models. They presented their conclusion, it's a comet, as if it were settled fact rather than the most likely interpretation of limited data. And this is where institutional credibility can become problematic. When NASA speaks with complete confidence based on incomplete evidence, they're not just stating scientific conclusions, they're shaping public perception, they're closing doors to alternative hypotheses, they're telling the world to stop asking questions because the experts have decided. But Avi Loeb, watching that press conference, didn't stop asking questions. He looked at those fuzzy images and saw something that troubled him deeply. He saw an institution making the same mistake they'd made with Oumuamua, the first interstellar object ever detected. Back then, NASA had quickly labelled it a comet despite it showing no cometary activity, only to later acknowledge it exhibited unexplained non-gravitational acceleration that still hasn't been satisfactorily explained by natural mechanisms. Loeb had questioned the Oumuamua narrative and been dismissed by many in the astronomy establishment, and now, watching NASA present blurry images of 3I Atlas with absolute confidence, he felt that same institutional certainty overwhelming careful scientific analysis. The government shutdown excuse deserves examination too. NASA claimed the several-week delay in releasing the images was due to federal offices being closed, preventing the team from processing and analysing the data. On the surface, that's a reasonable explanation. Government shutdowns do disrupt operations. Teams do get furloughed. Work does get delayed. But the timing felt convenient to many observers. 3I Atlas had been photographed in October, and the images weren't released until late November. That's more than a month of processing time even after factoring in the shutdown. Amateur astronomers had been posting their observations for weeks before NASA's official release. The narrative that government bureaucracy delayed the truth while private citizens documented it in real time became impossible to ignore. When those images finally appeared on screens around the world, accompanied by NASA's definitive statement that this was just another comet, the reaction was swift and divided. Some people accepted it immediately. NASA said it's a comet, case closed, let's move on. These are the folks who trust institutional expertise and don't see value in second-guessing scientific conclusions from authoritative sources. But another group, probably a larger group than NASA expected, felt deeply unsatisfied. They looked at the images and wondered why months of anticipation had led to something so unremarkable. They compared those images to what amateurs had captured and wondered why superior data wasn't being collected by superior equipment. And they heard NASA's confidence and wondered if that confidence was justified or performative. Avi Loeb was firmly in the second group. Within 48 hours of NASA's press conference, he published a blog post that would ignite a controversy still burning today. He didn't just say the images were low quality, he said they were deceptive. He didn't just say NASA's conclusion was premature, he said it was misleading. He accused the agency of presenting data in a way that shut down legitimate scientific inquiry, rather than encouraging it. And he backed up his accusations with specific technical criticisms that were impossible to dismiss as mere contrarianism. This wasn't a conspiracy theorist throwing wild accusations. This was a Harvard professor laying out a methodical case that something was seriously wrong with how NASA was handling the 3I Atlas observations. The images themselves told us less than NASA claimed. That's Loeb's central argument, and it's worth understanding precisely. The images confirmed that 3I Atlas exists. They confirmed it has a coma and tail. They suggested it's undergoing active outgassing. But they absolutely did not provide enough resolution to determine whether this was a natural comet or something else exhibiting comet-like behaviour. The difference between those two scenarios is astronomically important, but the image quality made distinguishing between them impossible. And yet NASA's entire presentation framed the question as already answered. That's not bad science. That's premature science. And when premature science comes from institutions with the authority to shape public understanding, it becomes something more concerning than mere error. It becomes narrative control disguised as scientific consensus. So now we understand what NASA showed us. We understand the images they presented, the conclusions they drew, and the confidence with which they delivered their verdict. But we still don't understand why a scientist like Avi Loeb would call this deceptive. We don't understand what he saw that NASA didn't want us to focus on, and we certainly don't understand whether his criticism has merit or whether it's just professional disagreement between scientists with different standards of evidence. To answer those questions, we need to understand who Avi Loeb is, why his voice carries weight, and what his track record tells us about whether we should take his accusations seriously. Because credibility matters in science, and when credibility goes to war with credibility, we need to know who to trust. When someone accuses NASA of deception, your first question should be, who is this person, and why should I believe them over an entire space agency? That's not skepticism, that's basic critical thinking. Anyone can make accusations on the internet, anyone can write a blog post claiming institutional corruption. But words only matter when they come from someone with the credibility to back them up. So let's talk about Avi Loeb, because understanding who he is will help you evaluate whether his criticism of NASA deserves your attention or your dismissal. Avi Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University. For 9 years, he chaired Harvard's astronomy department, one of the most prestigious academic positions in astrophysics. He's published over 800 papers in peer-reviewed journals on topics ranging from black holes to the early universe, from exoplanets to the cosmic dawn. He's received numerous awards for his contributions to theoretical astrophysics. He's been consulted by NASA, the Pentagon, and multiple international space agencies on matters of scientific importance. This is not someone operating on the fringe of his field. This is someone at the absolute centre of mainstream astrophysics. And yet, paradoxically, he's become known for something that makes many of his colleagues uncomfortable. He's willing to question scientific consensus when evidence suggests that consensus might be wrong. Loeb first gained widespread public attention with Oumuamua, the first confirmed interstellar object ever detected passing through our solar system. When astronomers discovered Oumuamua in October 2017, they initially classified it as an asteroid, then briefly as a comet, then settled back on asteroid when no cometary activity was detected. But Oumuamua exhibited something strange: non-gravitational acceleration. It was speeding up in ways that couldn't be explained by the sun's gravity, or by any visible outgassing that would produce thrust. NASA's explanation was that it must be outgassing something we couldn't detect, probably carbon monoxide or nitrogen, in a way that coincidentally produced acceleration without visible jets. Loeb looked at that explanation and found it unsatisfying. He published a paper suggesting an alternative. What if Oumuamua was a light sail, a thin reflective object being pushed by sunlight, possibly of technological origin? The response from the scientific establishment was swift and harsh. Many astronomers dismissed Loeb's hypothesis as sensationalism. They accused him of seeking publicity. They said he was giving credibility to conspiracy theories. But here's what's interesting: nobody definitively proved him wrong. They showed his hypothesis was unlikely, sure. They showed natural explanations were more probable, but the actual mystery of Oumuamua's acceleration was never satisfactorily resolved. To this day, we still don't have a completely convincing natural explanation for its behaviour. Loeb's technological hypothesis remains unlikely, but the question he raised, are we prematurely dismissing alternatives because they make us uncomfortable? That question remains valid. This is what makes Loeb both respected and controversial. He operates by a principle he calls scientific humility, which he defines as acknowledging how much we don't know and refusing to let institutional consensus shut down legitimate inquiry. He's not saying aliens are visiting us. He's saying we should collect enough evidence to know whether they are or aren't, rather than assuming they aren't and dismissing any data that complicates that assumption. That might sound like common sense, but in institutional science it's actually somewhat radical. Science operates on paradigms, frameworks of understanding that guide research and interpretation. Paradigms are useful because they organize knowledge, but paradigms can also become prisons, making it difficult to see evidence that doesn't fit the established framework. When Loeb watched NASA's 3i Atlas press conference, his concern wasn't that NASA was wrong about it being a comet. His concern was that NASA was expressing certainty where certainty didn't exist. In science, you're supposed to proportion your confidence to your evidence. If your evidence is strong and comprehensive, you can be confident. If your evidence is limited and low resolution, you should be tentative. NASA's images were objectively low resolution. They were objectively insufficient to rule out alternative explanations. And yet NASA's language was objectively confident. That mismatch between evidence quality and conclusion certainty is what triggered Loeb's criticism. Within days of the press conference, Loeb wrote a blog post that would be read by hundreds of thousands of people. In it, he didn't just complain about image quality. He systematically documented why NASA's conclusions weren't supported by the data they presented. He pointed out specific technical problems with the images, what astronomers call spacecraft jitter, where the camera moves slightly during exposure, creating blur. He explained why images affected by jitter couldn't provide the resolution needed to distinguish between natural and technological objects. He questioned why NASA emphasized what the images showed, comet-like appearance, and ignored what the images couldn't show, structural details, surface characteristics, precise shape determination. But Loeb went further than just technical criticism. He raised something that made many people uncomfortable. He suggested that 3I Atlas might not be a natural object at all, not in a sensational way, not in an attention-seeking way, but in a careful, methodical way that outlined specific observations that would settle the question. He pointed to anomalies in the object's behavior, unusual brightness patterns, unexpectedly precise trajectory, characteristics of its jets that didn't quite match known cometary physics. He wasn't declaring it was alien technology. He was asking whether we had enough data to rule that out, and arguing that we didn't. And he was criticizing NASA for acting as if we did. This is classic Loeb. He doesn't make wild claims, he doesn't speculate beyond what evidence supports, but he absolutely refuses to accept institutional certainty when that certainty is premature. He's comfortable being wrong. What he's not comfortable with is shutting down inquiry before questions have been properly investigated. And that's exactly what he saw NASA doing with 3I Atlas. By presenting low-quality images as definitive evidence, and declaring with confidence that the object was just a comet, NASA was effectively telling the scientific community and the public to move on. Nothing extraordinary to see here. Loeb looked at those same images and thought, we don't know enough yet to say that. The question you have to ask yourself is this: do we trust institutional authority or individual expertise when they conflict? That's not an easy question. Institutions have resources, teams of experts, decades of experience. Individual scientists, no matter how credentialed, can be wrong, can have biases, can get attached to ideas that don't pan out. But institutions can also be conservative, resistant to paradigm shifts, protective of established narratives. The truth is that science advances through tension between these forces, institutional stability providing continuity, individual iconoclasts forcing re-examination. The healthiest scientific environment is one where both are respected and neither is automatically believed. What gives Loeb credibility in this situation isn't just his academic credentials, it's his track record of being careful. When he suggested Oumuamua might be technological, he didn't write a book claiming aliens visited us. He published a peer-reviewed paper outlining why existing explanations were insufficient, and proposing a testable alternative. When that paper received backlash, he didn't retreat or double down emotionally. He engaged with the criticism, refined his arguments, and continued collecting data. His approach to 3I Atlas follows the same pattern. He's not claiming NASA is covering up alien spacecraft. He's claiming NASA is overclaiming confidence based on limited data, and he's pointing out specific ways we could collect better data to settle the question. This is important to understand as we move forward. Loeb isn't the antagonist in this story. NASA isn't the villain. This is a debate about scientific methodology, about standards of evidence, about how we should approach extraordinary questions. Loeb believes we should approach them with radical openness and proportional confidence. NASA, like most scientific institutions, believes we should approach them with established frameworks and default to conventional explanations until extraordinary evidence forces us to consider alternatives. Both positions have merit. The question is, given what we know about 3I Atlas, which approach is more appropriate? When Loeb wrote that NASA's images were deceptive, he wasn't attacking people's character. He was describing what happens when institutions present incomplete data as complete understanding. The images themselves weren't lies, but the framing of those images as providing definitive answers. That's where the deception enters. And Loeb's willingness to say that publicly, knowing it would generate controversy and potentially alienate colleagues, tells you something about his priorities. He values truth over comfort. He values inquiry over consensus, and he's willing to risk professional relationships to ensure questions get asked that need asking. So should you listen to him? That depends on what kind of thinker you are. If you believe scientific truth emerges from respecting authority and trusting institutional expertise, NASA's word should carry more weight. If you believe scientific truth emerges from constant questioning and proportioning claims to evidence, Loeb's criticism deserves serious consideration. The beauty of this particular controversy is that we don't have to choose based on philosophy alone. We have evidence. We can look at what NASA presented and what Loeb identified and evaluate for ourselves, whose position is better supported. That's what we're going to do next. Examine the specific technical problems Loeb identified with NASA's images and determine whether his criticism has merit or whether it's just professional disagreement getting blown out of proportion. Because the only way through this debate is with evidence, not with choosing sides based on credentials alone. Here's where we need to slow down and really understand what Avi Loeb is saying. Because if you don't grasp the technical problem, the entire controversy will seem like scientists arguing over details that don't matter. But these details do matter. They matter enormously. Because the question isn't whether NASA's images show a comet-like object. They clearly do. The question is whether those images provide enough resolution and detail to support NASA's confident conclusion that this is definitely just a comet and nothing else. That's the crux of Loeb's criticism. He's not saying the images are fake, he's saying they're insufficient, and insufficient evidence used to make definitive claims is, in his view, a form of scientific deception. Let's start with the basic technical problem, spacecraft jitter. When you take a photograph from a moving platform, any vibration or movement during the exposure creates blur. Think about trying to photograph a bird in flight while you're standing in a moving car. Even if your camera is sophisticated, even if the bird is clear in your viewfinder, the final image will be blurred because both you and the subject are in motion. Now multiply that challenge by taking the picture from a spacecraft orbiting Mars while trying to photograph an object travelling at cosmic speeds through interplanetary space. The Mars Reconnaissance Orbiter, which captured NASA's primary images of 3I Atlas, was never designed for this kind of photography. It was built to photograph the Martian surface, a stationary target directly below the spacecraft's orbital path. When MRO turned its camera toward 3I Atlas, it had to track a fast-moving target across its field of view, while the spacecraft itself was travelling thousands of miles per hour in orbit. The resulting images suffered from what engineers call jitter, tiny vibrations and tracking errors that accumulate during exposure time, creating blur. This isn't NASA's fault. This is physics. You can't point a camera designed for one purpose at a completely different target and expect perfect results. But here's where Loeb's criticism becomes sharp. If you know your images are compromised by jitter, if you know the resolution is insufficient for detailed analysis, you should communicate that limitation prominently. You shouldn't present those images as if they provide definitive answers. Loeb's blog post went into considerable detail about exactly what kind of information you need to distinguish between a natural comet and a technological object exhibiting comet-like behaviour. You need high enough resolution to see surface features, or at least structural characteristics. You need multiple images from different angles to determine three-dimensional shape. You need spectroscopic data detailed enough to identify specific molecular compositions, not just broad categories like water vapour present. You need measurements precise enough to detect subtle asymmetries in brightness or jet activity that might indicate non-natural processes. NASA's images provided almost none of this. They showed an elongated blob with a tail. That's important data, but it's incomplete data. It's not enough to justify the level of confidence NASA expressed. Now, NASA would argue, and has argued, that they have additional data beyond the images. They have spectroscopic measurements from multiple instruments. They have trajectory calculations. They have models of how comets behave when entering the inner solar system. All of that is true. But Loeb's point is that the images themselves, the visual evidence NASA chose to feature in their press conference, the evidence presented to the public as proof of 3I Atlas being a comet, that specific evidence doesn't support the conclusion. If NASA has other data that does support the conclusion, why center the presentation around inadequate images? Why not wait until better images were available? Why not be transparent about the limitations of what they were showing? This gets to a deeper issue about how scientific institutions communicate with the public. There's a tension between explaining uncertainty and providing clear answers. The public generally wants answers. They don't want to hear it's complicated or we need more data. They want to know, is it a comet or is it something else? NASA, understanding this public pressure, tends to provide clear answers even when the data is still ambiguous. That's not necessarily malicious, it's practical communication strategy, but it comes at a cost. When you provide clear answers based on ambiguous data, you're trading accuracy for clarity. You're simplifying in ways that can mislead, and you're shutting down public curiosity by suggesting questions have been settled when they haven't been. Loeb's criticism is that NASA prioritized narrative over nuance. They wanted to tell a clean story. Interstellar visitor enters solar system. We observe it. It's a comet. Interesting but not revolutionary. Everyone can relax. That narrative serves institutional purposes. It maintains credibility, avoids sensationalism, keeps public expectations managed. But what if reality is more complex than that narrative allows? What if 3I Atlas exhibits characteristics that don't fit cometary models perfectly? What if there are anomalies that deserve investigation rather than dismissal? By presenting low-quality images with high confidence, NASA effectively discouraged further inquiry. They signaled to the scientific community and the public that this topic was settled. Resources should be allocated elsewhere. Nothing extraordinary happening here. But Loeb looked at those same images and saw all the things they didn't tell us. He saw that the resolution was too poor to detect surface features. He saw that the elongated shape could be consistent with multiple explanations. He saw that the tail structure, while comet-like, didn't necessarily prove cometary origin, because technological objects could also create tails through various mechanisms. He saw that NASA's conclusion required assuming this was a natural object, and interpreting all data through that assumption, rather than considering whether the data might support alternatives. This is what scientists call confirmation bias. When you already believe something and interpret new evidence in ways that confirm your belief rather than challenge it. Now, confirmation bias isn't unique to NASA. It's a universal human cognitive tendency. All scientists are susceptible to it, including Loeb. But institutional science has a particular vulnerability to confirmation bias, because institutions have established paradigms they're invested in maintaining. When you've spent decades studying comets, when your expertise is in cometary science, when your career is built on understanding how natural comets behave, you're going to interpret ambiguous observations as consistent with comets. That's not dishonesty, that's how expertise works. You see new data through the lens of what you already know. The problem is when that lens becomes a filter that screens out alternative interpretations before they're seriously considered. Loeb's argument is essentially this: NASA's images of 3I Atlas are so low in quality that they function as a Rorschach test. You can look at them and see what you expect to see. If you expect a comet, you'll see features consistent with a comet. If you're open to alternatives, you'll see features that could support multiple explanations. The scientific method demands that when evidence is ambiguous, you don't pick the interpretation you prefer and present it as fact. You acknowledge the ambiguity, outline what additional data would resolve it, and collect that data before drawing definitive conclusions. NASA did the opposite. They took ambiguous images and presented an unambiguous conclusion. That's what Loeb means by deceptive. Let me give you a concrete example of what this looks like in practice. One of the key features NASA pointed to in their presentation was the tail structure of 3I Atlas. They showed images where you could see material extending behind the object, away from the Sun. This is classic cometary behavior. When a comet approaches the Sun, solar radiation heats the ice on its surface, causing it to sublimate and release gas and dust particles. Solar wind and radiation pressure push this material away from the comet, creating the characteristic tail that always points away from the Sun. NASA's images showed this tail, therefore they argued this confirms cometary nature. But Loeb pointed out something NASA didn't emphasize. The tail structure in their images was ambiguous. The resolution wasn't high enough to determine whether the tail was broad and diffuse, as you'd expect from natural outgassing, or narrow and collimated, as you might see from directed jets or technological processes. This distinction is crucial. Natural comets produce tails that spread out widely because the outgassing happens randomly across the surface in response to solar heating. If 3I Atlas were producing an unusually narrow focused tail, that would be anomalous. It would suggest something other than random heating was driving the outgassing. But NASA's images were too blurry to tell. The tail looked comet-like if you assumed it was comet-like, but it didn't provide independent confirmation. This pattern repeated throughout NASA's presentation. Every piece of evidence they offered was consistent with a comet if you assumed it was a comet, but didn't independently prove it was a comet. The coma, consistent with cometary outgassing, but also consistent with other mechanisms that produce dust and gas around an object. The brightness. Consistent with reflecting sunlight off an icy surface, but also consistent with reflecting sunlight off any reflective material. The trajectory. Consistent with gravitational dynamics of a comet passing through the solar system, but also consistent with any object following a similar path. Nothing NASA showed ruled out alternatives. They just presented the comet interpretation as if it were the only interpretation. And this is where institutional credibility becomes a double-edged sword. When NASA says it's a comet, most people believe them because NASA is NASA. They have expertise, they have resources, they have a track record of getting these things right. But that credibility can also shield weak conclusions from appropriate scrutiny. If a random blogger made the same arguments NASA made based on the same quality of images, scientists would rightfully point out the arguments weren't well supported. But because NASA made them, those arguments got accepted as authoritative. Loeb's role in this controversy is essentially to apply the same scrutiny to NASA's claims that would be applied to anyone else's. And when you do that, the claims start to look much less solid. The core technical problem, the one Loeb keeps returning to, is resolution. NASA's images simply don't have enough pixels on target to show fine detail. Imagine trying to determine whether a distant object is a bird or a drone by looking at a photograph taken from several miles away. If the object is just a few pixels across, you can see that something is there, you can see that it's moving, you might even see a general shape. But you cannot distinguish between natural and technological explanations based on that level of detail. You need closer photographs, higher resolution, multiple angles. With 3I Atlas, NASA presented the equivalent of that distant low-resolution photograph and declared confidently, "It's a bird." Loeb looked at the same photograph and said, "You can't possibly know that from this image quality." Now, NASA has defended their position by pointing out that HiRISE and other instruments captured the best data possible given the constraints. 3I Atlas was discovered relatively late, didn't pass particularly close to any of our spacecraft, and was moving fast. These are legitimate challenges. Nobody is saying NASA should have magically produced perfect images when perfect images weren't technically feasible. But Loeb's criticism isn't about what NASA could have captured. It's about what they claimed based on what they did capture. If your data is limited, your conclusions should be limited. If your images are blurry, your certainty should be modest. NASA's images were blurry, but their certainty was absolute. That's the disconnect. And here's why this matters beyond just scientific accuracy. How we frame discoveries affects how we fund future research, how we allocate telescope time, how we prioritize which questions deserve deeper investigation. By presenting 3I Atlas as a settled question, just another comet, nothing extraordinary, NASA essentially removed incentive for the broader scientific community to study it intensively. If it's just a comet, why devote precious resources to additional observations? Why compete for time on Hubble or James Webb to study something that's already understood? But if 3I Atlas might be something more unusual, if there are genuine anomalies that deserve explanation, then studying it intensively becomes a scientific priority. NASA's confident conclusion had the effect, intentional or not, of reducing scientific interest in this object. And that troubles Loeb deeply, because he believes 3I Atlas deserves far more attention than it's getting. So we've established that NASA's images have serious quality limitations, and that those limitations should temper confidence in conclusions drawn from them. But Loeb didn't stop at criticising image quality. He went much further. he identified specific anomalies in 3i Atlas's behaviour that don't fit standard cometry models. He documented characteristics that, even if the images were perfect, would still raise questions about whether this object is what NASA says it is. These are the 13 anomalies that form the core of Loeb's alternative hypothesis. And now that we understand why the images themselves are problematic, we need to examine what those anomalies are and whether they're as significant as Loeb claims, because if they are, then NASA's certainty isn't just premature, it might be wrong. Now we get to the heart of why Avi Loeb isn't just complaining about image quality. Yes, NASA's photographs were disappointing. Yes, the resolution was inadequate for detailed analysis. But blurry images alone don't make a scientist accuse a space agency of deception. What makes Loeb's criticism so pointed is that he's identified specific anomalies in 3i Atlas's behaviour, characteristics that don't fit comfortably within our understanding of how natural comets behave. These aren't wild speculations or statistical quirks that disappear with better analysis. These are documented observations that deserve explanation, and NASA's public presentations largely glossed over them in favour of emphasising comet-like features. So let's walk through these anomalies systematically, and you can judge for yourself whether they justify Loeb's scepticism. The first anomaly involves the object's trajectory. Interstellar objects entering our solar system should arrive from random directions in the sky. The galaxy is vast, and there's no particular reason why visitors from other star systems would arrive from any specific direction more than any other. They're travellers from random points in space following random paths that happen to intersect with our solar system. Except 3i Atlas didn't arrive from a random direction. Its trajectory is remarkably precise, approaching Earth with a geometry that brings it unusually close for an interstellar object. Loeb calculated the probability that an interstellar visitor would naturally follow a path bringing it this close to Earth at this particular time, and the odds are extraordinarily low. Not impossible, but improbable enough that it raises questions. Why this path? Why this timing? Random chance is a valid answer, but it's a statistically uncomfortable answer. The second anomaly concerns what astronomers call jet collimation. When comets outgas, they release material somewhat randomly across their sun-facing surface as ice sublimates from solar heating. This creates relatively broad, diffuse jets of material spreading outward in various directions. But observations of 3i Atlas, including data NASA collected but didn't emphasize, suggest its jets are unusually narrow and consistent. They don't spread out the way you'd expect from random heating. They maintain coherent structure across distances where natural jets should dissipate. This is peculiar. Highly collimated jets can occur in nature under specific conditions, but they're uncommon, especially in comets. And when you combine unusually focused jets with other anomalies, the oddness compounds. Third is brightness behaviour. Comets typically follow predictable brightness patterns based on their distance from the Sun. As they approach the Sun, they brighten because more ice sublimates and creates larger comas that reflect more sunlight. As they move away, they dim. 3i Atlas has shown brightness variations that don't quite match this standard model. Its brightness has fluctuated in ways that suggest either irregular shape causing variations as it rotates, or variable outgassing that doesn't correlate perfectly with solar distance, or both. Again, natural explanations exist for both scenarios. Comets can have irregular shapes. Comets can have variations in surface composition that cause uneven outgassing. But the specific pattern of 3i Atlas's brightness changes is at the edge of what standard models predict. It's within the range of possible. But at the unlikely end of that range, the fourth anomaly involves mass estimates. When you observe how much material a comet is ejecting and how bright its coma appears, you can estimate how much mass it must have. Multiple teams have attempted these calculations for 3i Atlas, and the results are puzzling. The amount of outgassing activity visible suggests either the object is very small and losing mass rapidly, which means it shouldn't be this active for this long, or it's larger than it appears, which means it should be brighter. The numbers don't quite balance. NASA's interpretation is that they need better data to refine the calculations. Loeb's interpretation is that the inconsistency might indicate the object isn't a simple ice ball following standard physics. Both interpretations have merit, but only one of them invites further investigation rather than assuming better data will resolve the discrepancy. Fifth is the discovery timing. 3. I Atlas was discovered not at vast distance when entering our solar system, as you might expect for an interstellar visitor, but relatively close to Earth, relatively late in its passage through the inner solar system. Why wasn't it detected earlier? Possibly because it wasn't bright enough until it approached the Sun and became active. But that raises a question. If it's only now becoming detectably active, what was its state before entering the solar system? Natural comets from our Oort cloud are cold and dark until solar radiation activates them, but interstellar comets should have been cold and dark for millions of years travelling through deep space. The fact that 3I Atlas became active exactly when expected for a solar system comet, despite coming from interstellar space, is slightly odd. It's exactly what you'd expect if this were a local comet, not quite what you'd expect for an interstellar visitor that's been frozen for eons. The sixth anomaly is spectroscopic. Observations have detected water vapour and some organic compounds in 3I Atlas's coma, exactly as you'd expect from a comet. But the ratios of different compounds, the relative abundances of molecules, don't quite match the standard compositional profiles of comets we've studied extensively from our solar system. They're similar, but off. NASA interprets this as evidence that interstellar comets formed under different conditions than solar system comets, so naturally their composition differs slightly. That's perfectly reasonable, but it's also consistent with an object that's not entirely made of natural cometary material, that might have components or characteristics that skew the spectroscopic readings in unexpected ways. Both explanations fit the data. One is conventional, one is speculative. NASA chose the conventional one. Loeb is asking whether we've collected enough data to rule out the speculative one. Seventh is rotational behaviour. Many asteroids and comets rotate, tumbling through space because of their formation history and collisional past. You can detect rotation by watching how brightness changes periodically. Some preliminary observations of 3I Atlas suggest rotational behaviour, but the period doesn't match well with what you'd expect for a natural object of its estimated size and shape. It's rotating faster than seems likely for a loose pile of ice and rock. Fast rotation isn't impossible in natural bodies, especially if they're denser than typical comets, but combined with everything else, it adds to a picture of an object that's slightly atypical in multiple ways simultaneously. Eighth, and this is where things get statistically interesting, is the probability calculation. Loeb performed an analysis based on known rates of interstellar objects passing through our solar system, trajectories of previously detected visitors, and the discovery rate suggesting how many we're missing because they're too faint or fast. Based on those numbers, he calculated how often you'd expect an interstellar object to pass close enough to Earth to be easily observable. The answer, extremely rarely, on timescales of centuries or longer. And yet here's 3I Atlas, the third interstellar object we've confirmed, passing conveniently close to Earth with convenient timing for observation. Is that just luck? Possibly. But Loeb points out that if interstellar visitors are far more common than models suggest, that itself requires explanation. And if they're as rare as models suggest, then the timing and geometry of 3I Atlas is almost too convenient to be coincidental. He calculated odds suggesting it's many thousands of times less likely than random for this specific trajectory to occur naturally at this specific time. Statistics like that don't prove anything, but they demand attention. The ninth anomaly concerns non-gravitational acceleration. This is the smoking gun from Oumuamua, and it's showing up again with 3I Atlas. When you track an object's position over time, you can calculate its orbit based on gravitational forces from the Sun and planets. If the object is following a purely gravitational trajectory, your prediction should match observations precisely. But both Oumuamua and 3I Atlas have shown small deviations from purely gravitational paths. They're accelerating slightly in ways gravity alone doesn't explain. With comets, this is usually attributed to outgassing creating thrust, like a rocket engine. Gas jets pushing material in one direction create reaction force pushing the comet in the opposite direction. That's standard physics, but the amount of non-gravitational acceleration observed for 3I Atlas doesn't perfectly match the amount of outgassing visible. It's accelerating slightly more than expected for the level of activity we see. Again, measurement uncertainty could explain the discrepancy, or the outgassing could be asymmetric in ways we're not detecting, or something else could be providing thrust. NASA assumes the first two explanations. Loeb asks whether we've ruled out the third. 10th is the December approach. This might sound like it doesn't belong in a list of anomalies, but bear with me. The fact that 3i Atlas will pass extremely close to Earth in December, coming within optimal observing range of our best telescopes, is itself statistically unusual. Most interstellar objects passing through our solar system don't come near Earth. They zip through the system following hyperbolic trajectories that take them through the plane of planetary orbits and back out into deep space, often without passing particularly close to any planet. 3i Atlas is approaching Earth closely enough that even moderate-sized telescopes will capture excellent data. That's incredibly fortunate for science. But it's also, from a statistical standpoint, unusual. Loeb doesn't claim this proves anything. He's simply noting that when you add up all these individually unusual characteristics, the cumulative improbability starts to feel less like a string of coincidences and more like something that deserves careful investigation. 11th is something more subtle, something NASA mentioned in technical papers, but not in public presentations. 3i Atlas appears to have a slightly different dust-to-gas ratio than typical comets. When comets outgas, they release both gas molecules and dust particles that were frozen in the ice. The ratio between dust and gas tells you about the comet's composition and structure. Most comets cluster around a certain ratio range. 3i Atlas is just outside that range. Not dramatically, but noticeably. This could mean interstellar comets have different formation chemistry, or it could mean this isn't a typical comet. The data is preliminary, and better spectroscopic observations will refine it. But right now, it's an anomaly without a definitive explanation. 12th involves the coma structure. High-resolution images from amateur astronomers show that 3i Atlas's coma isn't perfectly symmetrical. There are subtle asymmetries, regions where material seems more concentrated, patterns that suggest either complex outgassing from an irregular nucleus, or possibly structural features affecting how material is released. Natural comets often have asymmetric comas because their surfaces are irregular, and outgassing happens preferentially from certain regions. But the specific asymmetries in 3i Atlas are, according to Loeb, worth closer examination. He's not claiming they're impossible to explain naturally. He's claiming they're one more data point in a larger pattern of slightly unusual characteristics. 13th, and this is perhaps the most philosophically interesting anomaly, is what Loeb calls the selection effect problem. How do we know what's normal for interstellar objects when we've only studied 3 of them? Oumuamua was weird. Borisov, the second interstellar object, seemed more comet-like but was observed only briefly. Now 3i Atlas shows comet-like features, but with multiple oddities. What if interstellar objects are just inherently stranger than solar system objects because they form under different conditions, travel through different environments, and arrive at our solar system with histories we can barely imagine? In that case, calling 3i Atlas anomalous might be misleading. It might be perfectly normal for an interstellar visitor to exhibit all these unusual characteristics. But that's exactly Loeb's point. We don't know what's normal. We don't have enough data. And pretending we do, declaring confidently that this is just a comet when we barely understand what interstellar comets should look like, is premature closure of scientific inquiry. Now, it's crucial to understand that Loeb isn't claiming these 13 anomalies prove 3i Atlas is technological. He's claiming they prove we don't have enough information to say definitively what it is. NASA looked at this object and saw comet-like features, so they concluded comet. Loeb looked at the same object and saw comet-like features plus multiple anomalies, so he concluded, we need better data before concluding anything. That's the fundamental disagreement. It's not about evidence so much as about standards of proof. NASA operates on a paradigm where natural explanations are assumed correct, until extraordinary evidence forces alternatives. Loeb operates on a paradigm where assumptions should be minimal and conclusions should wait for sufficient evidence to rule out alternatives. Which approach is more scientifically valid? There's no simple answer. Science needs both. It needs the conservative stability of assuming natural explanations, because most phenomena are natural, but it also needs the critical questioning of whether assumptions are justified in each specific case. With 3i Atlas, we have an object that mostly looks like a comet, but has enough unusual characteristics that dismissing those characteristics as unimportant might be premature. That's Loeb's argument. And when you line up all 13 anomalies in sequence, when you recognize that each one individually might not mean much, but collectively they form a pattern, his skepticism starts to feel less like contrarianism and more like appropriate scientific caution. Here's what's important to remember. These anomalies are documented. They're not speculations or misinterpretations. They're observations from multiple independent sources, including NASA's own instruments. The disagreement isn't about whether these anomalies exist. It's about what they mean and how we should respond to them. NASA's response is to fit them within existing frameworks, explain them with natural processes, and move forward with confidence. Loeb's response is to acknowledge we don't fully understand them, admit that current explanations have gaps, and advocate for more intensive study before declaring the case closed. Both responses reflect valid scientific philosophies. The question is, given the stakes of potentially misidentifying an interstellar visitor, which philosophy should we prefer? And that brings us to one of the most embarrassing aspects of this entire controversy, and something that calls into question NASA's handling of this observation campaign and validates many of Loeb's criticisms about institutional priorities. Because while NASA was producing blurry images and declaring confident conclusions, a group of amateur astronomers using backyard equipment was capturing far superior data that revealed details NASA's presentation completely missed. This isn't just a technical footnote. This is a fundamental indictment of how resources were allocated and how priorities were set. And it's the part of this story that makes even NASA defenders uncomfortable. If you want to understand why millions of people were frustrated with NASA's 3i Atlas presentation, I can summarize it in one sentence. Amateur astronomers with backyard equipment captured better images than a space agency that spends billions of dollars on observation infrastructure. Let that sink in for a moment. Private citizens using telescopes they purchased with personal funds, operating from their homes without institutional support, managed to photograph an interstellar visitor with more clarity and detail than NASA's spacecraft could achieve. This isn't a small embarrassment. This is a fundamental question about resource allocation, institutional priorities, and whether NASA is optimizing for scientific discovery or for maintaining control over narrative. The hero of this particular chapter is a British amateur astronomer named Paul Craggs. Craggs operates a personal observatory from his property in the UK, equipped with a moderate-sized telescope and camera system that probably cost him a few $1,000s. A significant personal investment certainly, but a rounding error compared to NASA's budget. When 3i Atlas entered observable range, Craggs pointed his telescope at the coordinates and began capturing images. What he saw and successfully photographed was remarkable. A clearly elongated nucleus, sharp definition of the coma structure, visible jets of material extending from specific points on the surface, and an extensive tail showing fine detail and structural features. His images weren't blurry blobs, they were actual photographs showing real structure. But Craggs wasn't alone. In Japan, an amateur astronomer named Mitsunori Tsutsumi captured similarly impressive images using his personal equipment. Tsutsumi's photographs showed the same elongated shape, the same detailed tail structure, and something even more interesting: clear evidence of the asymmetric jets Loeb had predicted might be present. The jets weren't broad and diffuse as you'd expect from random cometary outgassing. They appeared focused and consistent, exactly the kind of anomalous behavior that Loeb had been emphasizing, and NASA had been downplaying. And Tsutsumi captured all of this from his backyard, using equipment that fits in a typical shed. Within days of NASA's official press conference, these amateur images began circulating online. Astronomy forums exploded with discussion. Social media filled with side-by-side comparisons of NASA's fuzzy spacecraft images and the amateurs' sharp ground-based photographs. The contrast was damning. Here was the most advanced space agency in human history, with orbital platforms specifically designed for imaging, presenting data that looked worse than what hobbyists were achieving. The public reaction was swift and harsh. Why were we funding billion-dollar spacecraft if private citizens could outperform them? What was NASA even doing if their professional observations were inferior to amateur efforts? The criticism wasn't coming from conspiracy theorists or NASA haters. It was coming from the astronomy community itself, people who love space exploration and support NASA's mission, but couldn't understand how this had happened. NASA's response was defensive but technically accurate. They explained that ground-based telescopes have certain advantages for observing objects in specific geometries. They pointed out that spacecraft like the Mars Reconnaissance Orbiter were designed for planetary observation, not interstellar object tracking. They noted that amateur astronomers had the flexibility to optimize their observation times and telescope pointings in ways spacecraft with fixed orbits couldn't match. All of these explanations are valid. Ground-based telescopes absolutely can outperform space-based instruments under the right conditions. But these explanations missed the emotional and philosophical point that critics were making. If ground-based observations were superior, why didn't NASA emphasize data from Earth-based professional observatories rather than featuring their own inferior spacecraft images? Why center the press conference around their weakest data? This question cuts to the heart of institutional behavior. NASA had access to data from major ground-based observatories. They collaborate regularly with professional facilities that operate far more powerful telescopes than any amateur could afford. If they wanted high-quality images to show the public, they could have featured photographs from Keck Observatory, or the European Southern Observatory, or any number of professional facilities that were also observing 3I Atlas. But they didn't. They chose to feature their own spacecraft data, even though that data was obviously inferior. Why? Because featuring NASA data reinforces NASA's centrality to the story. It maintains the narrative that space exploration requires institutions like NASA. It justifies budgets and missions by showcasing NASA's unique capabilities, even when those capabilities aren't actually the best available. Institutional incentives push toward featuring them anyway. Avi Loeb seized on this amateur success as validation of his broader criticism. He wrote extensively about how Craig's and Tsutsumi's images revealed details that NASA's presentation had obscured. The sharp photographs confirmed what Loeb had suspected. 3I Atlas has structural characteristics worth studying intensively, details that low-resolution images simply couldn't show. The elongated shape wasn't just blur from jitter, it was a real feature of the object. The asymmetric jets weren't artifacts. They were actual outgassing patterns that demanded explanation. Everything Loeb had been arguing about the need for better data was vindicated by amateurs who simply pointed good telescopes at the target and took careful photographs. But the amateur success raises uncomfortable questions beyond just image quality. It suggests that the bottleneck in observing interstellar visitors isn't technology or funding. We have the technology, and individual citizens can afford it. The bottleneck is attention and prioritization. Amateur astronomers observed 3I Atlas intensively because they were excited about it, because it was a once-in-a-lifetime opportunity for them to contribute meaningful data about an interstellar visitor. Professional astronomers, operating within institutional constraints, had to compete for telescope time, justify observations to committees, and balance 3I Atlas against countless other scientifically important targets. The institutional process filtered out some of the enthusiasm and urgency that drove amateurs to capture excellent data. This creates a strange dynamic where passionate individuals can sometimes outpace institutions precisely because they're not constrained by bureaucratic processes. They don't need approval to observe. They don't need to justify why this target deserves attention over that target. They can just do it. And in this case, doing it meant capturing some of the best images of 3I Atlas that exist. NASA eventually acknowledged the amateur contributions, incorporating some of their data into subsequent technical analyses. But that acknowledgement came quietly, in scientific papers, not in press conferences. The public narrative remained focused on NASA's spacecraft observations, even though those observations were demonstrably inferior to what amateurs had achieved. Loeb used the amateur images in his own analysis, citing them as evidence supporting his concerns about 3I Atlas's anomalous characteristics. The sharp photographs showed details of jet structure that wouldn't be visible in blurry images. They showed asymmetries in the coma that raised questions about what was causing them. They provided visual confirmation that this wasn't just a simple, icy rock with standard cometary behavior. And crucially, they proved that better data was possible. If amateurs could capture these details, then professional facilities with far superior equipment should be able to capture even better data. The question was whether those professional facilities were being directed to observe 3I Atlas intensively, or whether NASA's confident declaration that it was just a comet had discouraged intensive study. The Internet's reaction to amateur astronomers outperforming NASA was a mix of celebration and frustration. Celebration because it demonstrated the power of citizen science, the way passionate individuals can contribute meaningfully to human knowledge even without institutional backing. Frustration because it highlighted waste and misallocation in how public funds are spent on space observation. If a few $1,000s of personal equipment can capture better images than billion-dollar spacecraft, what exactly are we funding when we fund NASA? That's an unfair question in many ways. NASA does things amateurs can't, like land rovers on Mars and send probes to the outer solar system. But it's a question people asked anyway, and it's a question NASA struggled to answer satisfactorily. For Loeb, the amateur images were proof that his call for better observations was not only justified but achievable. He pointed to Craig's and Tsutsumi as examples of what becomes possible when you prioritize data quality over institutional control. He argued that if NASA truly wanted to understand 3i Atlas, they should be coordinating intensive observation campaigns using the best available instruments, regardless of whether those instruments were NASA-operated. The goal should be knowledge, not credit. But institutional incentives don't always align with that goal. Institutions want credit for discoveries. They want to be the source of definitive answers, and that desire can sometimes work against the open, collaborative approach that produces the best science. So now we have a clear picture of the controversy's major elements. We have NASA presenting low-quality images with high confidence, declaring 3i Atlas to be just a comet. We have Avi Loeb pointing to image quality problems and documented anomalies, arguing that confidence is premature. And we have amateur astronomers capturing superior data that reveals details NASA downplayed, validating Loeb's criticism and embarrassing the institution that should have been leading the observation campaign. That's the situation. But we haven't yet heard NASA's full defense, their explanation for why their conclusions are justified despite all these criticisms, and fairness demands we understand their perspective fully before rendering judgment on who's right. Science isn't a courtroom, but sometimes it resembles one, especially when credible experts disagree publicly about interpretations of data. So far we've heard primarily Avi Loeb's case against NASA's handling of the 3i Atlas observations. Now we need to hear the defense, NASA's explanation for why their conclusions are scientifically justified, despite the criticisms Loeb has levelled. Because while Loeb's arguments are compelling, NASA isn't staffed by fools. They have reasons for their confidence, and those reasons deserve fair examination before we decide whose position is better supported. Amit Kshatriya, speaking on behalf of NASA at the November press conference, and in subsequent interviews, has consistently maintained that the evidence clearly supports identifying 3i Atlas as a natural comet. His argument rests on several pillars. First, every observable characteristic of the object is consistent with cometary behaviour. It has a coma, indicating active outgassing of volatile materials heated by solar radiation. It has a tail oriented away from the sun, showing that solar wind is pushing released material exactly as cometary physics predicts. Its spectrum shows water vapour and organic compounds, the chemical signature of cometary composition. Its brightness varies with solar distance in ways consistent with heating and cooling of an icy body. Everything, according to NASA, points to comet. Second, NASA argues that the anomalies Loeb identifies are either within the range of natural variation or are artifacts of incomplete data that will resolve with better observations. The unusual trajectory, statistically improbable but not impossible, and interstellar space is vast enough that improbable events happen regularly somewhere. The tight jet collimation? Preliminary observations might be misleading. Better data could show the jets are more diffuse than current images suggest. The master brightness inconsistencies, measurement uncertainties and model limitations that will improve as more data accumulates. The non-gravitational acceleration, classic cometary outgassing providing thrust, exactly as observed in countless solar system comets. For every anomaly Loeb presents, NASA has a conventional explanation that fits within established physics and doesn't require invoking extraordinary hypotheses. Third, NASA emphasizes the burden of proof principle. In science, extraordinary claims require extraordinary evidence. Suggesting that an interstellar visitor might be technological is an extraordinary claim, possibly the most extraordinary claim you can make in astronomy. The evidence supporting that claim needs to be overwhelming, unambiguous, and resistant to conventional explanations. Right now, according to NASA, the evidence for 3i Atlas doesn't meet that threshold. Everything can be explained naturally. Some explanations require stretching standard models slightly, sure, but they don't require breaking physics or invoking intelligence. When you have conventional explanations that work, you go with those until evidence proves them inadequate. That's not closed-mindedness, that's scientific methodology. Fourth, NASA points to their experience and track record. They've studied hundreds of comets over decades. They've analysed data from dozens of missions. They've refined models of cometary behaviour through extensive research. When they say something behaves like a comet, that conclusion is backed by institutional expertise and accumulated knowledge that no individual researcher, regardless of credentials, can match. Avi Loeb is brilliant, NASA acknowledges, but he's not a cometary specialist. He's a theoretical astrophysicist whose expertise is in other areas. NASA's Planetary Defense Coordination Office, which led the 3I Atlas observations, is staffed with people who dedicate their careers specifically to understanding small solar system bodies. Expertise matters, and in this case, NASA claims their expertise supports their conclusion. Fifth, NASA defends the image quality by explaining the technical constraints they faced. The Mars Reconnaissance Orbiter wasn't designed to track fast-moving interstellar objects. Repurposing it for that task was improvised and came with inevitable limitations. But they argue the images, while not perfect, were sufficient to confirm the object's cometary nature. You don't need ultra-high-resolution photographs to determine basic classification. The presence of a coma and tail visible even in lower-resolution images is diagnostic. Everything else is additional detail that's interesting but not essential to the fundamental identification. They also point out that spectroscopic data, which is often more important than visual images for determining composition, clearly supported the comet hypothesis. Images get public attention because they're visual and understandable, but scientists rely more on spectroscopy and other quantitative measurements. Sixth, and this is where NASA's defense becomes more philosophical, they argue against premature speculation. One of science's roles is to provide the public with accurate information and to counter misinformation. When a Harvard professor publicly suggests an interstellar visitor might be technological without definitive evidence supporting that suggestion, it opens the door to wild speculation, conspiracy theories, and public confusion. NASA sees part of their mission as providing clear, evidence-based communication that doesn't oversell mysteries or encourage unfounded theories. By stating confidently that 3I Atlas is a comet, they're trying to provide public clarity and prevent the kind of runaway speculation that happened with Oumuamua, where alternative hypotheses generated sensational headlines and misled many people about the state of the scientific evidence. But here's where NASA's defense runs into problems that even some of their defenders acknowledge. While all their arguments have merit, they don't fully address Loeb's core criticism. Not that NASA's interpretation is impossible, but that their confidence outpaces their evidence. You can say everything is consistent with a comet without demonstrating that everything uniquely points to a comet, as opposed to other explanations. Consistency isn't proof, and when you present conclusions with certainty based on consistency rather than proof, you're potentially shutting down inquiry prematurely. NASA's appeal to expertise is valid but double-edged. Yes, institutions have accumulated knowledge and experience, but institutions also have biases, blind spots, and resistance to paradigm shifts. History is full of cases where institutional consensus was wrong and individual skeptics were right. That doesn't mean Loeb is necessarily right now, but it means NASA being more expert doesn't automatically make them more correct. Expertise needs to be demonstrated through argumentation, not just asserted through authority. The burden of proof argument is philosophically interesting. Loeb isn't claiming 3I Atlas is definitely technological. He's claiming we don't have enough evidence to rule it out, and therefore we should collect more evidence before declaring the case closed. That's not an extraordinary claim requiring extraordinary evidence. That's a call for appropriate epistemic humility. NASA frames the debate as natural comet versus alien spacecraft, which makes their position seem obviously reasonable. But Loeb is framing it as premature certainty versus appropriate caution, which makes his position seem reasonable. How you frame the question shapes what counts as a good answer, and NASA's defense of image quality, while technically accurate, doesn't address why they chose to feature those images so prominently when better ground-based data existed. It doesn't explain why amateur astronomers outperformed them. It doesn't justify why their press conference centered on their weakest data, rather than collaboratively presenting the best available data regardless of source. These are institutional and communication failures, not scientific failures, but they're failures nonetheless. What's clear from NASA's defense is that they genuinely believe their interpretation is correct. This isn't a cover-up or conspiracy. These are scientists doing their best to interpret complex data using established frameworks, but belief, even expert belief, isn't the same as proof. And Loeb's criticism fundamentally questions whether belief should be stated as confidently as NASA has stated it, given the quality and completeness of the evidence. Both sides are arguing in good faith. Both sides have scientific reasoning supporting their positions. The disagreement is about standards of evidence and appropriate levels of confidence, which are ultimately philosophical questions as much as scientific ones. What would settle this debate definitively is simple: better data. And fortunately, better data is coming. December will bring 3i Atlas to its closest approach to Earth, putting it in optimal range for observation by the most powerful telescopes humanity has built. When that happens, we'll get resolution orders of magnitude better than anything currently available. We'll get detailed spectroscopy that can identify specific molecular compositions. We'll get trajectory measurements precise enough to settle questions about non-gravitational acceleration. We'll get the evidence needed to determine whether NASA's confidence was justified or whether Loeb's caution was appropriate. So before we try to resolve this debate through argument, let's look at what December observations will actually measure and how they'll provide answers that rhetoric cannot. Let's talk about the question that makes many scientists uncomfortable, the hypothesis that Avi Loeb has been carefully exploring while most of his colleagues dismiss it out of hand. Could 3i Atlas be technological? Not definitely, not certainly, but possibly. Could this interstellar visitor have artificial rather than natural origins? Before you dismiss this as science fiction, before you assume anyone asking this question is unserious, understand that Loeb isn't asking it frivolously. He's asking it because the scientific method demands we consider hypotheses that fit the evidence, test them against observations, and only rule them out when data definitively contradicts them. And right now, the hypothesis that 3i Atlas might have technological components hasn't been ruled out. It's just been assumed away. Here's what a technological origin hypothesis might look like. Stripped of sensationalism and grounded in physics, imagine an object launched from another star system millions of years ago, travelling through interstellar space for eons before entering our solar system. During that journey, it accumulates ice on its surface from the thin molecular clouds that drift through the galaxy. Not because it's made of ice, but because any object moving through space for long enough will gradually accumulate material. By the time it enters our solar system, it's covered with a layer of frozen water and organic compounds. When it approaches the sun, that accumulated ice begins to sublimate, creating a coma and tail exactly like a natural comet. From a distance, it looks like a comet. It behaves like a comet. But underneath the accumulated ice is something else entirely. This scenario explains why 3i Atlas appears comet-like without being a natural comet. It explains why spectroscopic observations detect water vapor and organics. It explains the coma and tail. But it also potentially explains the anomalies. If the object has internal structure or components that affect how it sheds material, that could create the unusually collimated jets. If it has mass distribution different from a natural ice ball, that could explain the brightness and mass inconsistencies. If it's capable of minor course corrections, that could explain non-gravitational acceleration beyond what visible outgassing should produce. If it was sent intentionally, rather than arriving randomly, that could explain the statistically improbable trajectory bringing it close to Earth. Loeb isn't claiming this is what 3i Atlas actually is. He's demonstrating that this hypothesis fits the available evidence at least as well as the natural comet hypothesis, and possibly better when you account for the anomalies. He's pointing out that we don't have data that definitively rules this out, and he's arguing that when you have a hypothesis that explains observations without violating physics, you should take it seriously enough to design observations that could test it rather than dismissing it because it sounds unlikely. The technological hypothesis generates testable predictions. If 3i Atlas has artificial components beneath accumulated ice, you'd expect certain observable characteristics. The jets should show unusual symmetry or consistency, as they might originate from specific points rather than from random solar heating. The object might exhibit slight trajectory adjustments that can't be fully explained by outgassing thrust. Its rotation rate might be unusual for a natural body of its apparent composition. Its spectrum might show trace elements or isotopic ratios inconsistent with natural solar system or interstellar compositions. None of these predictions are unfalsifiable science fiction. They're all testable with sufficiently precise observations. NASA's counter-argument is that invoking technology is unnecessary, because natural explanations exist for everything. That's true, but Loeb's point is that natural explanations exist doesn't mean natural explanations are sufficient. When you have multiple anomalies that each require stretching natural models, when you have statistical improbabilities that require invoking unlikely coincidences, when you have behaviours that sit at the edge of what natural processes should produce, maybe the more parsimonious explanation is that something genuinely unusual is happening. Parsimony usually favours natural explanations, but not always. Sometimes the simpler explanation is that something doesn't fit the natural category because it isn't natural. Consider the possibility from another angle. If interstellar civilizations exist anywhere in our galaxy, and if any of them have developed the capability to send probes or objects beyond their star systems, then our solar system over billions of years should have been visited by at least some of those objects. The galaxy is billions of years old. There's been plenty of time for technological civilizations to arise, spread, and leave artifacts drifting through space. We've detected 3 interstellar objects passing through our solar system in just a few years of watching for them. How many have passed through undetected throughout Earth's history? Thousands? Millions? If even a tiny fraction of those were technological rather than natural, we should expect to eventually detect one. Maybe Oumuamua was one, maybe 3i Atlas is another, or maybe they're both natural and we're just seeing patterns where none exist. But the question is scientifically legitimate. This is where the philosophy of science becomes crucial. There's a principle called the principle of mediocrity, or Copernican principle, which says we shouldn't assume we're special, or that our observations are unique unless evidence forces us to. If interstellar travel is possible, it's probably been achieved by someone somewhere during the galaxy's long history. If probes or artifacts have been launched, some should have passed through our neighbourhood. If we're detecting interstellar objects now, we should be open to the possibility that not all of them are natural. Dismissing technological hypotheses out of hand because they seem unlikely is actually violating the principle of mediocrity. It's assuming that just because we haven't developed interstellar technology, nobody has. Loeb has been careful to distinguish between different types of technological hypotheses. He's not suggesting 3i Atlas is an alien spacecraft actively exploring our solar system. That would require invoking intelligence currently operating it, which raises questions about intent and behaviour that go beyond what evidence supports. He's suggesting it could be a probe, an artifact, something sent long ago that's now just drifting through space like any other object, no longer functional or operational, just an ancient relic that happens to be passing by. That's a much more modest claim than aliens are visiting us, and it's a claim that fits naturally into plausible scenarios about how advanced civilizations might explore their galaxy. The critical observation is that technological and natural hypotheses make different predictions that upcoming observations can distinguish between. Natural comets should show relatively smooth, continuous outgassing that responds predictably to solar heating. Their jet structures should be broad and variable, as different surface regions rotate into sunlight and heat up. Their composition should match known cometary profiles, perhaps with some variations reflecting different formation environments. Their trajectories should be entirely explainable by gravitational forces plus predictable outgassing thrust. Technological objects with accumulated ice might show more structured, consistent jet behaviour. They might have compositional peculiarities. They might show tiny trajectory adjustments. They might have unexpected density or mass distributions. December observations will measure all of these characteristics with unprecedented precision. Hubble Space Telescope will image 3i Atlas at resolutions far exceeding anything currently available. James Webb Space Telescope will conduct spectroscopic analysis detailed enough to identify specific molecules and isotopic ratios. Ground-based observatories will track its position with precision sufficient to detect non-gravitational accelerations at levels orders of magnitude smaller than currently measurable. Within weeks, we'll have data that will either confirm NASA's comet hypothesis definitively, or reveal anomalies so stark that even skeptics will have to acknowledge something unusual is happening. Loeb has stated publicly that December observations will determine the true nature of this object. He's not hedging or retreating to unfalsifiable claims, he's making a clear prediction that sufficient data will resolve the question. If December data shows perfectly standard cometary behaviour with no significant anomalies, Loeb will presumably acknowledge he was overcautious and NASA was right to be confident. If December data reveals unexplainable anomalies or characteristics inconsistent with natural origin, NASA will need to revisit their conclusions. This is how science is supposed to work, disagreement resolved by collecting better data, not by arguing about philosophy or authority. But here's what's important regardless of what December reveals. The conversation itself has value. By forcing the scientific community to seriously consider alternative hypotheses, by demanding that conclusions be proportioned to evidence quality, by insisting that anomalies be explained rather than dismissed, Loeb is performing a crucial function in the scientific ecosystem. Even if he's ultimately wrong about 3i Atlas specifically, he's right about the broader principle that science advances by questioning assumptions and demanding rigorous standards of proof before accepting conclusions. The technological hypothesis isn't about believing in aliens, it's about being methodologically open to possibilities that fit evidence, even when those possibilities challenge comfortable assumptions. It's about recognizing that the universe is stranger than we imagine, and sometimes the strange explanation is the correct one. It's about acknowledging that we're in the earlier stages of developing the capability to detect interstellar objects, and we shouldn't be surprised if the first few we study turn out to have characteristics we didn't expect and don't fully understand. Whether those unexpected characteristics result from natural processes we haven't encountered before, or from technological processes we've never seen, humility demands we gather sufficient evidence before declaring certainty. So now we're left with a clear understanding of both positions. NASA sees a comet and believes the evidence supports that identification. Loeb sees anomalies and believes we need better data before making definitive identifications. Both positions are scientifically defensible, given different standards of evidence and different methodological approaches, but debating which position is more reasonable only takes us so far. What we really need is the December observations that will provide the decisive evidence both sides agree will settle this question. So let's look at exactly what those observations will measure, how they'll be conducted, and what they'll tell us about whether this interstellar visitor is a simple comet, an unusual natural object, or something that forces us to rethink our assumptions about what travels through the cosmos. December is coming, and with it, the moment of truth. In just a few weeks, 3i Atlas will reach its closest approach to Earth, passing within optimal viewing range of humanity's most powerful telescopes. This isn't speculation or prediction, this is orbital mechanics, as certain as gravity itself. The object is on a trajectory that brings it near enough that even the limitations that plagued earlier observations will be overcome by sheer proximity. We're about to get the data that will settle every argument, answer every question, and determine whether NASA's confidence was justified, or whether Avi Loeb's caution was prescient. This is the observation campaign that both sides have been demanding, and it's going to happen whether institutions prioritize it or not, because the object itself is cooperating by coming to us. Let's talk about what December observations will actually involve. Hubble Space Telescope has already secured observing time for 3i Atlas during its close approach. Hubble's imaging capabilities at this distance will resolve features orders of magnitude smaller than anything previously visible. If the object has surface structure, if it has discrete outgassing vents, if it has any kind of irregular shape or texture, Hubble will see it. The images will be sharp enough to distinguish between a homogeneous icy body and something with mechanical complexity. They'll show jet sources precisely, revealing whether outgassing happens uniformly across the sun-facing surface or originates from specific points. This alone could settle major questions about whether the object behaves like a typical comet or shows characteristics requiring alternative explanations. James Webb Space Telescope, the most powerful infrared observatory ever built, will conduct spectroscopic analysis more detailed than any previous instrument could achieve. Webb doesn't just detect what molecules are present in 3i Atlas's coma, it identifies specific isotopic ratios, measures relative abundances precisely, and detects trace elements at concentrations that would have been invisible to earlier spectroscopy. If 3i Atlas has unusual composition, isotopic signatures that don't match solar system or expected interstellar chemistry, unusual ratios of organic compounds, trace metals or elements inconsistent with natural comet formation. Webb will detect it, and if those compositional anomalies exist, they'll demand explanation. Ground-based observatories worldwide are coordinating observation campaigns. Major facilities including Keck Observatory, the Very Large Telescope, and numerous others will be pointed at 3i Atlas continuously during its close approach. They'll measure position with extraordinary precision, tracking the object across the sky and calculating its trajectory to levels of accuracy that will definitively settle questions about non-gravitational acceleration. If the object is deviating from a purely gravitational path by even tiny amounts, and if that deviation can't be explained by visible outgassing, we'll know. The data will be unambiguous, and multiple independent facilities capturing the same measurements will eliminate any possibility of error or misinterpretation. Thermal observations will measure how much heat 3i Atlas emits, and how that thermal signature changes with solar distance. Natural comets have predictable thermal behavior based on their composition and size. Ice sublimates at specific temperatures, creating cooling as energy goes into phase change. If 3i Atlas shows thermal characteristics that don't match models of natural cometary heating and cooling, that's another data point requiring explanation. Modern infrared instruments can create thermal maps showing temperature distributions across the object's surface. If those distributions are uniform, that suggests simple natural heating. If there are anomalous, showing hot spots or cold spots that don't correspond to expected solar illumination, that requires understanding what's causing those patterns. Rotation measurements will be refined to high precision. By watching how brightness varies as the object rotates, astronomers can determine rotation period, axis orientation, and potentially shape. If 3i Atlas is tumbling like a natural body with irregular shape, we'll see characteristic brightness variations. If it's rotating with unusual stability, or if the rotation rate doesn't match what you'd expect for its apparent size and composition, that's meaningful data. Some asteroids rotate extremely fast because they're solid metal or rock that can withstand centrifugal forces. Ice and rock rubble piles can't rotate as fast without flying apart. If 3i Atlas is rotating too fast for a natural comet of its size, that tells us something about its internal structure. The jet structure will be mapped in detail. Current observations show jets exist and suggest they might be unusually collimated. December observations will definitively characterize those jets, their width, their consistency over time, their response to changes in solar illumination as different parts of the surface rotate into sunlight. Natural cometary jets vary somewhat randomly as surface features rotate and different ice deposits sublimate. If 3i Atlas's jets maintain suspicious consistency, if they don't vary the way natural jets should, if they show geometric patterns that seem too regular, those observations will be documented unambiguously. Multiple telescopes watching simultaneously will eliminate any possibility that what we're seeing is instrumental artifact or observational error. Mass estimates will be refined through careful trajectory analysis. When an object outgasses, the thrust from release material changes its trajectory slightly. The amount of trajectory change depends on the object's mass. By measuring both the trajectory changes and the amount of material being ejected, you can calculate mass. If those calculations give consistent results that match the object's observed size and assumed composition, that supports natural origin. If the mass seems wrong, too high or too low for the apparent volume and composition, that's an anomaly requiring explanation. December observations will have enough precision to make these calculations reliable rather than speculative. The critical thing to understand about December is that these observations aren't speculative proposals or things that might happen if funding materializes. These are scheduled observations, telescope time is allocated, international coordination is happening. The astronomical community recognizes this is a special opportunity. Interstellar objects pass through our solar system rarely, and 3i Atlas's close approach means it will be observable with unprecedented detail. Even skeptics of Loeb's hypotheses agree this object deserves intensive study. Scientific curiosity alone justifies the observation campaign, regardless of whether you think the object is likely to be extraordinary or mundane. Avi Loeb has been explicit that December data will settle the debate. He's written that these observations will determine conclusively whether 3i Atlas is a natural comet or something requiring alternative explanation. That's not hedging language. That's a clear statement that evidence will resolve uncertainty. If the data shows standard cometary characteristics with all anomalies explained by natural processes, Loeb will have to acknowledge his concerns were overcautious. Science doesn't allow moving goalposts when predictions fail. If December observations vindicate NASA's position, that vindication will be clear and undeniable. But NASA is equally exposed to being wrong. If December reveals characteristics that can't be fit into natural cometary models, if the anomalies prove to be genuine rather than artifacts of incomplete data, if any measurements come back showing signatures inconsistent with natural origin, NASA's confident assertions will look premature at best. The institution that declared definitively this is a comet based on incomplete evidence will have to explain why they expressed certainty before possessing data that justified it. Scientific credibility takes years to build and moments to damage. NASA's willingness to declare conclusions confidently before December observations represents a gamble that the data will vindicate them. From a public perspective, December transforms this controversy from abstract scientific debate into concrete reality. We won't be arguing about philosophy or methodology or standards of evidence. We'll be looking at actual high-resolution images, actual spectroscopic data, actual measurements. Either those measurements will show a normal interstellar comet and this entire controversy will be remembered as much ado about nothing, or they'll show something that forces the scientific community to seriously reconsider assumptions about what travels between the stars. There's no third option. The data will be definitive one way or another. What makes this moment historically significant is timing. We're living through the first years when detecting and studying interstellar objects has become possible. Our observation capabilities have reached the threshold where we can notice visitors from other star systems and characterize them before they leave. We've detected exactly 3 so far: Oumuamua, Borisov, and now 3I Atlas. Each one has been strange in different ways. Each one has raised questions that weren't fully answered. We're building our understanding of what interstellar objects look like, how they behave, what's normal for them versus what's anomalous. December observations of 3I Atlas will be the most comprehensive study of an interstellar visitor ever conducted. Whatever we learn will shape how we think about these objects for years to come. The broader implications extend beyond one object. If 3I Atlas turns out to be just a comet, that's important information. It tells us interstellar space contains icy bodies similar to our Oort cloud comets. It suggests that planetary system formation produces similar objects everywhere, that chemistry and physics produce comparable outcomes regardless of where you are in the galaxy. That's reassuring in its way. The universe is comprehensible, our models work, the strange is usually natural. But if 3I Atlas turns out to have characteristics we can't explain naturally, that's transformative information. It means interstellar space contains objects we didn't anticipate. It means our models are incomplete. It means the universe is stranger than we thought, and we need to expand our frameworks to accommodate realities we hadn't imagined. Either outcome teaches us something crucial. Either outcome advances science. The worst outcome would be continued ambiguity, December data that's good but not quite good enough, leaving the debate unresolved and extending uncertainty indefinitely. But that seems unlikely given the observation plans, the instruments being deployed, the coordination happening, the multiple independent facilities focusing simultaneously on the same target. All of that should produce data that definitively answers the questions both NASA and Loeb have raised. So we wait. Not long now. Within weeks we'll know. The object is approaching, the telescopes are ready, the observation schedules are set, and when the data comes in, when the images are processed and the spectra analysed and the measurements calculated, we'll finally have the answer to this controversy that's captivated millions. Is 3I Atlas just another interstellar comet, interesting but fundamentally familiar? Or is it something that forces us to question our assumptions about what's possible, what's natural, and what might be travelling through the cosmic ocean that surrounds our tiny island? I'll be covering December results the moment they're released. Every major finding, every image, every measurement that sheds light on this mystery. We'll examine it together and determine whether NASA's confidence was justified or whether Loeb's skepticism was vindicated. This story isn't over. The most important chapter is about to be written, not by human argument, but by reality itself revealing its nature through evidence. Subscribe if you want to be here when that revelation happens. because missing it would mean missing one of the most important astronomical observations of our generation. Hit the notification bell so you don't miss the follow-up video when December data drops, and drop a comment with your prediction. Do you think 3i Atlas will turn out to be a natural comet vindicating NASA, or will it show anomalies vindicating Loeb's caution? Your answer might reveal more about your philosophy of science than about the object itself, but we'll all know the truth soon enough. December is coming, and with it, the revelation we've been waiting for.